Hey guys, welcome back. And today I have a really amazing question for you all. This question says that the user will enter a number and you have to print even or odd depending on the number without using conditionals. So here's the twist. Without using conditionals means that you can't use if else, you can't use switch, and you can't use ternary operators depending on your language. For my language, which means this Python, I can't use if, elif, and else statements. If you want, you can pause the video and try it yourself. If you pause the video and tried it, that's amazing. If you didn't, I'm going to show you the logic. First, I'm going to write the logic of the code. So def test number, it accepts a number, right? And then it prints it. Very simple. So for that, I have this logic. Number modulus 2 and print odd double equals to none or print even. Okay. Oops. Didn't mean to do that. Now print actually just test number. Oops. Again test number 10. Let's write Python question 3.py. It says even because our 10 is even. We can also convert it into this format like that, and again we can say 5 odd, and again 3 odd, 12 even, and here we go. So this is our first logic. Let's see how this is working. What is this weird thing? So this complete logic is based on something that we skipped while we were studying. So this logic is called short circuiting. Okay, so what is short circuiting? So short circuiting means that depending on what operator you use, the AND operator or the operator, your the second condition will be checked or won't be checked if the first condition is a true. So I'm gonna repeat that. Okay, so that means that if I type true and I type and print checked, if I save this and I run it, you see checked is called. Okay, the checked is displayed, and the reason why checked is displayed, my bad, that wasn't called. So the reason why this is displayed is because the print statement must be executed in order that it is getting displayed on the command line, right? And the reason is the short circuiting. The short circuiting in an AND operator states that if the first condition is true, then the other condition should be true also in order for the complete operation to be a true, right? That's what an AND is. AND says a 1 and 1 is a 1, right? A true and a true is a true. So if the first condition is true, it is going to check the second condition. If the first condition is false, then it won't check the second condition. Okay, we understand this logic, right? Now if I just change it to an OR and I save and run this, it didn't print the checked this time. And the reason is the OR says if 1 and 0, still it's gonna give us a 1. So true and true or false is still going to be a true, right? And that's how it works. If the first condition is true, then the OR operator won't check the second condition, and as it is not checking the second condition, it doesn't need to check the second condition. It don't need to come to this part, and if it didn't came to this part, then the checked is never printed. Very simple. So now we know that if I do something like false, so can you guess the output? If you guessed checked will be printed, then that's right. The reason is now the first operator or the first um, value or expression is false, right? So the OR operator we say, okay, the first one is false. Let's try to check if the second one is true, because still we have a chance to get a true value, right? These all operator tends to become true, right? So the first one is false, so it thinks that we might get a true here on the right hand side. So it evaluated this to check whether this is getting evaluated into a true, right? And this thing gets, printed because it is called by the OR, right? Not called but executed. So that's the reason, and that's the same logic I applied right over here. So this is like this number. So in the case of the 12 here, the number is storing 12, right? So 12 modulus 2 will give us a 0, right? That's a modulus operator. So the remainder is 0. So 0 is a false, right? If this is a false, then we don't need to check the other one. We don't need to check this print, right? That's an AND. If one is false, then the complete thing is false, which means that this complete thing is a false. Okay, be with me. This complete highlighted thing is a false. Okay, and then we are checking if this complete highlighted thing is equals to none. And I just said this complete thing is equals to false. And false and none are not equal, which means now this complete thing is a false. Now, if the first part of an OR is false, then we know that it will, evaluate the next part, and which it did, and printed even. Get it? Now I'm gonna run it again for an odd value. I'm gonna tell you how this works. Number is equals to 5. This becomes 1. The modulus of 5 modulus 2 is 1, right? This becomes 1, and which means true. If this value is true, then AND needs to evaluate the second part. So it evaluated the second highlighted part, and it says that now it evaluated this part, right? So it has to print this in order to evaluate it. So it printed odd, right? So odd is printed already. Now this is saying that now this complete thing will become equals to none. Let me show you why. The reason is, if I do true and none, then you see we get a none. So a true and none is none. So this becomes true. 5 modulus 2 equals to 1. True and none. The reason why we are getting none in this part is because if I print something, because the pre-default return value of print is none. Just make this, place it like this. You see none. So the basic return of a print statement is none. So this complete thing get evaluated into a none, right? So this complete thing gets evaluated into a none, and this equals to none, right? So now the first part has become a none. If the first part of an OR is none, then because of short circuiting, the second part won't be evaluated. Okay, that was really hard, right? Now there's one more quick way. I saved this for the end, otherwise you won't wait, right? Test number 2. Number and I can just simply do even, odd of number modulus 2, and I can just print it. um I'm like, okay, I know you guys will be mad. Input again, we run this. 12 even, 12 even, and I think that's the easier one, right? 12 comes here, 12 modulus 2 gives us 0, so even is printed. For all the odd values, the odd will be printed. So I really hope that you understand how short circuiting works and you really like this question. And there's a GitHub link attached below. So if you want to get the code, you can also get that, and you can ask your own questions here also. So thanks for watching.